and Training and Research, Ministry of Education, Government of India. He has received his PhD degree in Faculty of Information and Communication Engineering from Anna University. He has completed his master's degree in Microwave or Optical Engineering from Madurai Kamaraj University and bachelor's degree in Electronics and Communication Engineering from University of Madras. Sir has also obtained his master's degree in Business and Administration from TNOU. Sir is having experience of 30 years, out of which more than 28 years in training of technical teachers in India and abroad. He has worked in Colombo Plant Staff College, Manila, Philippines, as faculty consultant and chairman of the Information and Communication Technology Division for nearly 4 years on Government of India deputation. He is an accredited for Asia Pacific Accreditation and Certification Commission, Philippines. He has also been Acting Director General of CPSC and Acting President of APACC for more than 1 year. His vast area of interest include biomedical engineering, computer networking, communication engineering, virtual instrumentation, telemedicine, cyber physical systems, and Internet of Things, instructional design, delivery systems, ICT application and teaching learning process, TVET, and accreditation. He has published more than 100 papers in international and national conferences, journals, and seminars. He has visited around 20 countries and conducted different quality improvement programs everywhere. He has received many prestigious awards from different organizations. He is a member of many international and national professional bodies, including Institute of Electrical and Electronics Engineering, American Society of Engineering Education, and International Vocational Education and Training Association. He is a fellow of the Institution of Electronics and Telecommunication Engineers, fellow of Institute of Engineers, and presently chairman of IEEE Technology and Engineering Management Society, IEEE TEMS Madras chapter. We are honored and privileged to have Professor Dr. G. Kurandevel with us today for this session. I am sure his knowledge and insights would provide us clarity and understanding. Now, I request a resource person to take over the session. Sir.
Sir, please unmute your mic, sir.
Hello. Sir, change the microphone. Hello. Is it audible? No.
Yes, sir, it is audible, sir.
Okay. Thank you. So now it's okay. Eh?
Yes, sir.
Yeah, thank you. So screen is also visible. Okay.
Yes, sir, it is clear.
Okay. So, respected management officials of St. Joseph College of Engineering, participants from different parts of India. I'm really happy that the college, this one, they have arranged nearly an great initiative by conducting this type of program, because when our coordinator Dr. Chinna Muthan told about this program, I was really happy that you are conducting a recent technology. Okay, the 6 days online Atal faculty development, especially on smart communications in IoT, security and future applications and possibilities is really a great topic. So this is going to be a really useful one for all of you, because this is what we are going to see in future. Wherever you are going to see, yes, this will be there. The technology will be there. So congratulations to the principal, management, coordinator Dr. Chinna, and other co-coordinators, faculty and staff members for initiating this program. So thank you also for inviting me, and I could see a lot of eminent speakers are giving a talk on different topics. So today we'll be discussing about, especially on Industry 4.0 to 5.0 we have changed. The main applications we call Industry 5.0 is going to change from the present version to a new version. Simple example I can tell you, like a robot. All these days, if a robot is there, assume I am having a robot. In case if I take my hand like this, middle, so suddenly the robot used to cut. It doesn't know what is happening. But in future, you are going to have the picture what I have put. You are going to have the robots which are going to have more sensitive. So it will know that a human being is coming, hand is there, so it has to stop. Whenever a human being is going to meet another person, how it will be, similar to that we are going to have in future. So we should be ready for this. So the technology is going to be full autonomous cars we are going to see. For example, I am traveling to a distance. Anyway, I am now in another part of India, Karnataka. I am there. I am basically from Nitter, Chennai. So now I have come for another meeting here. So assume I want to go back to Chennai now by car. When I booked a Ola or Uber car, what will happen? We are going to have a driver. He will come and wait. He'll call me, sir, I am here in front of your house or in front of hotel or in front of your institute. But in future, I am going to get only a message, and I am going to tell that that car is there waiting. But when I go, nobody is going to be there. So only a car is going to wait for me. So I have to go there, use my OTP, access the system. Means I have to just tell, after sitting, keeping all my luggage, yes, proceed or start activation something. So immediately my car will go. Whatever my brain is doing, the car is going to do. All with the help of these technologies, especially like IoT concept is going to be there. So you are going to have everywhere sensors, surrounded by sensors, which is going to communicate. So the sensors are going to be like my eyes. So the sensors will pick up the data in the road signal. Something like yellow to red it is going to reach. So what I'll do, whenever I see a yellow to red, I usually slowly apply brake and reduce acceleration. So the same thing is going to happen here. So you are going to see the sensors are going to receive the signal, and these signals are going to be traveling to a remote computer. We call it as cloud computer, where this AIML is going to be there. Okay, artificial machine learning, which may be working with deep learning, and it is going to do the processing. It is going to act as a brain, and it is going to get the signal from the computer, remote computer or cloud computer. Signal will be transmitted to that car where you have the real accelerator brake. So accelerator will reduce automatically, brake will be applied automatically. Just imagine, I am telling this itself is taking more than 1 or 2 minutes, but your topic is on next generation communication. Imagine the sensor to, first the sensor to pick up the data. Then the picked up data should go to the cloud computer. From the cloud computer, all the analysis should be done, just like a brain. Then brain is going to tell my leg, or here, similarly the brain computer is going to tell the actuators that this has to be done. So all these things should be happening in a fraction of a second. So this is what is going to happen in the case of this autonomous car. So where we are going to have all these features. Okay, we cannot imagine. Okay, it is already in operation, but we are going to have this concept. So we should be ready for this. So the technology is going to change such that everywhere you are going to see this type of vehicles. Or you take a drone. So in future you are going to see a drone which is going to flow. Okay. So whatever you do, like agriculture area, if you take, you are going to see that. So everywhere agriculture means you are going to see that. Where what will happen? Simple example, you are going to have something like a moisture sensor. Okay. Yes, I will be changing. Yes, please. You are going to change, you are going to see the moisture sensor. So whatever you do, you are going to see that drones are going to fly, or it is going to give like a agriculture spray, it is going to do automatically. Or if you are going to have a moisture sensor, it is going to take the threshold value and it is going to automatically start the sprinkler. This is what is going to happen. So all these things we call industrial revolution. Okay, so industrial revolution, what is happening? You are going to have automatically, you are going to have this thing. Okay, you take anything, you take a olden days, we started with mechanization. So people started with mechanization where all the data used to be there. Okay. Mechanization, water, steam, power started in 1800. And industry 2.0, we started mass production, electric power assembly line. Industry 3.0, it was computer, automated production, electronics. So most of us might have seen this. Okay. Industry 3.0, senior people. We are done doing this. And industry 4.0, everybody, whatever we have seen all these days, whether it's a cyber physical system, Internet of Things, networking, machine learning concept, so which is going to be changed as industry 5.0, which is human robot collaborations, cognitive systems, customizations are going to do. So where you see here, mainly I want to emphasize the period they are saying, approximate only your thing. Okay, it is around 120 years it took for the industry 1.0. And for industry 2.0, it took nearly 70 years. Then it took nearly 30 years, 3 to 4. But now, 4 to 5, it is within 20 years. We started getting all these things from internet and networking, communication system, data sourcing, or distributor value chain, or remote production, cyber physical systems. So all these things are going to come latest. So what I want to say is, everybody should be ready for this thing, Industry 5.0, where the smart communication is going to help us. Anyway, different experts have given a lot of idea about the communication also. So I want to show you a real example. And what I want to tell you, everyone, because there is a sustainable development goals we call. On 25th September 2015, all the countries, like in the world, around 193 countries in the world, they frame something sustainable development goals, where we have 17 goals. If you see the goal number 4 is quality education. You see goal number 8 is good jobs and economic growth. 9 is innovation infrastructure. Okay. So, like 11 is sustainable cities and communities. Whatever you see, like reduce inequalities number 10, or 17 is partnership for the goals. So all these things are interlinked. As a teacher or as a student, we, every citizens, are responsible for this. Each country has to report about the sustainable goals, how we are achieving every year. So as a teacher, I'm telling, we have to give goal number 4, quality education, by which all our students will get good skills. So we have to make our students to be Industry 4.0 or now Industry 5.0 ready, so that they'll be able to get the skills and they'll be able to get the job. So once they get a job, goal number 4 is quality education. We are giving good skills, quality education. So my students are going to get good job. Means you see, number 1 is no poverty. Number 2 is no hunger. Number 3 is good health. Once a student, boy or girl, get a job, in turn, she with her or his father, mother, no poverty, no hunger, good health. After his or her marriage, spouse, husband or wife, then their children, they will get a job. So this is the concept. So you have to individually work with this. So every student to get a job. In case student is attending, so it is your responsibility to get skills from the teachers with the latest area, and you have to get a job. Then you have to take care of the family. This is what is happening. That's why quality education, ensure inclusive and equitable quality education, promote lifelong learning opportunities for all. So this is what is happening everywhere. We have to make it. Similarly, everybody should know about NEP 2020, that is National Education Policy 2020, where they started giving lot of importance for this teacher education. Okay, whatever is happening like Atal or other programs or for teacher education, also reimagining vocational technology or professional education, promoting high quality research. Okay, so also the technology use and integration, and whatever we have to do, it is for our optimal learning we have to make. We have to support to the students. So that is what I want to do. Every one of us should start working with all these areas. Whether it's robotics or simulation or system integration or Internet of Things, cyber security, cloud computing, additive manufacturing, augmented reality, virtual reality, extended reality, mixed reality or metaverse or 360. Okay, whatever view, everything they call, including the big data, all these things are interlinked. Don't think that I am from mechanical, I don't want other things, I want only automobile. No, because if you take autonomous car, you might have seen all the electronic items or communication things. So electronic things are happening, communication is there. Or you take all the electric vehicles related, electrical engineering is there, computer, IT, all these things are linked. So I want every teacher who is working with this to interact and do with common thing. Okay, don't think that I am from particular brand. That is why now interdisciplinary is given more value. So if you see, these are all like manual. Slowly it happened those days. But now all these things are replaced with the technology. As the year goes, mechanization of labor has gone from electric to information to intelligence. Now everything changed to symbiotic. Similarly, if you see those days, mechanical production, steam power to division of labor, electric energy, then electronics, automation, IT system to smart, intelligent manufacturing. Now everybody is in the human centricity or resilient manufacturing. So we should be ready for these things. So everyone, we are responsible for this industry 2.0, 3.0, 4.0 or 5.0, which is going to make us as a very important thing. Because why we are talking about these things? So the communication, whatever we say, why people are giving more importance is, you see the total world population. So in 2050, it was around 7.3 billion. Slowly, 2030, it changed to 8.2 billion. Now in 2050, it is 9.6 billion. That is, percentage increase is 32%. But population over 65%, you see, 600 million was there, 973 million they are expecting in 2030, but in 2050 we are expecting 1.5 billion. We cannot imagine, okay, that much senior people are going to be there. Billion is, the India population is 45 crores. We call 1.45 billion. So that much Indian population level we are going to have in the world for the senior citizens. Why I am telling this? Sir, why should I buy, sir, whatever number is there? No. The technology, what we are talking, Internet of Things, which is going to really help you. I'll discuss related to smart health, where you can see what is going to happen in smart health. So if I want to take a ECG, so what I do? I go to a hospital, then they connect me, right arm, left arm, right leg, left leg, chest they put 6 leads, and we do this. But what is going to happen is, so I used to go to the hospital or lab center and I do. But now the technology has come. Assume there is a watch is there with me. Apple Watch is there, just I have to touch like this for 30 seconds. Once I touch for 30 seconds, so within 30 seconds, I am able to get these things. Okay, I am able to get this. Okay, that means within fraction of second, it is going to give me the real thing. Okay, within 30 seconds, I am going to get the ECG waveform. Then why should I worry? Okay, it is going to be like this. Just observe this video, hope it is visible. So just within the 30 seconds,
I'm at the UCSF Medical
I'll be
Center
getting
hooked
this.
up to a 12-lead EKG. Now I'm going to compare the results of this test versus the 1-lead EKG on the Apple Watch.
So this, she is a reporter. She is going to compare real ECG. She is connecting the real, okay, like right arm, left leg, chest lead. Parallelly, she is going to connect her watch. There is an optical sensor which is going to generate the ECG waveform. So it will not be there only. It is going to be in the mobile. Okay, it is going to be in the mobile. She is going to get it. Okay. And not only there, it is going to be there traveling to long distance. A doctor who is at a remote place or in the hospital, in the centralized hospital information, they are going to see. So the patients or even myself or whoever, even I am not patient, my ECG will be monitored by a doctor. He or she is going to get the report, whatever issue is there. Just observe that video, then I'll tell you.
If I look at my apps now, I'll notice that there's now an EKG app, these squiggly lines over here, and it's pretty simple to use. I just put my finger on the digital crown and it starts taking the EKG, counts down for about 30 seconds. And it actually shows it live as it's happening.
So we see that you have these two narrow beats, and then intermittently you have this wider early beat. That one right there, that one right there. So normal, early, normal, early. And that matches what we see on the EKG, where you have normal, and why. So this would be really useful to screen for this, or to have the first understanding that you have these early beats. It wouldn't tell us precisely where in the heart, apart from the fact that it's coming from the lower chamber, whereas this 12-lead EKG that gives us essentially a fuller picture can tell us precisely where in the lower chamber it's coming from.
And am I going to die? Is something wrong with me?
You are not going to die. These early beats are very common. In some people, they can lead to problems in the long term.
But let's take a look at how this actually works on the Apple Watch. An update to watchOS gave users access to two FDA-cleared features on the Apple Watch: an irregular heart rhythm notification and an EKG app exclusive to the Series 4, both of which could warn users of potentially life-threatening heart conditions. Heart rate is not new to the Apple Watch or wearables in general.
So the optical sensor on fitness trackers or smartwatches essentially uses changes in light that is reflected based on the pulse.
When the heart beats and more blood is pumped into the vessels, more light gets absorbed. Between beats, when there's less blood, more light gets reflected back into the receivers. The Apple Watch also uses this optical sensor to measure heart rhythm and alerts users when the pattern suggests atrial fibrillation, a heart condition which can increase your risk of stroke and other serious heart complications.
So the heart rate is the frequency of the heartbeat over time, but doesn't tell you anything about the pattern of those beats. The rhythm has more to do with the relative spacing of those beats.
But to get a definitive diagnosis, the doctor needs more information.
We would want to have an electrical confirmation of a diagnosis of atrial fibrillation before we decide on acting on that, and not base it in general on the pulse recording alone.
That's where the EKG comes in. The EKG, or electrocardiogram, uses electrodes to measure the electrical activity that results from each expansion and contraction of the heart. The Apple Watch has one electrode on the back crystal and one electrode on the digital crown. Place your finger on the digital crown to close the circuit and stay still for 30 seconds to get a read.
So that's creating the same sort of connection between your left arm and your right arm.
But the results from the single lead EKG on the Apple Watch, which users can share as a PDF with their doctors, gave Dr. Marcus enough information to detect my early heartbeat and could help doctors reach a diagnosis sooner.
And so there's this hope that we might detect those people who otherwise didn't know they had atrial fibrillation, and then treat them appropriately. The flip side is that we recognize there's a risk of false positive results.
The Apple Watch is the only direct-to-consumer device with a built-in EKG. But there are other devices like the Cardioband that let you take an EKG outside the doctor's office. Apple Watch competitors like Garmin and Fitbit are also working to improve their heart rate monitoring as more tech companies focus on healthcare as a way to breathe new life into wearables. I probably don't have AFib, but I would have never known about my early heartbeat without an EKG. And now I might just have to pay another visit to Dr. Marcus to get it checked out.
Okay, so this is what is going to happen. So what I want to say is, the technology is there like this, which is going to help us. Okay, you see here, this is going to helpful for this much billion of people. We will be able to get it. Okay, that is the main advantage. Wherever you are in the world, you can say, now I am outside Chennai, but my ECG can be checked by a doctor who is at the remote place. So this is the real applications which is going to help the people. So we should be ready for this thing. Okay. So the real technology, how it is going to help us, we'll try to see this. Okay. For all these things, I have to have the real technology like this. So where we are going to have the people are going to have the communication, whatever the next generation communication, or it may be 4G communication or now 5G communication. We are going to have 6G communication, because wherever we are using inside our house or inside our institutions or offices, industries, we are using Wi-Fi communications, and outside we use the mobile data communications. Because I can recall the development of communication when internet started. Okay, I can just tell internet when started, it was around 1995, we had the real thing. Okay, the conference happened 1996. We are able to get the what is that, PSTN connectivity. It was able to get the PSTN connectivity, where it was able to have, like, we call public switch telephone network. Okay, public switch network, PSTN we call public switch telephone network, or PSTN connectivity, where it was possible for me to have only 56 kbps connectivity. 56 kbps, we cannot imagine that. Okay, and those days I wanted to show the internet connectivity for my students, where it was really difficult for me to have the connectivity for even to show the website just for 2 minutes video. It was not possible for me to do this, but it was really difficult because of the connectivity. I think senior, again I'm telling, it was, they might have experienced with this PSTN or PDF, PDP, where it was nearly very difficult task. The speed was only 56 kbps. Okay, then slowly the concept changed. Okay, so where ISDN concept started coming. Anybody ISDN? Integrated Services Digital Network. Integrated Services Digital Network, where the speed was only around, I think, 64 kbps. The speed was only 64 days. Okay, so we had only 64 kbps program. Okay, so I can multiply that 64 to 128, 128 to 256, 256 to 512 kbps, 512 to 1024 kbps, which was called, really it was called a great thing. Okay, 1 Mbps connectivity. So those days I was really happy. So the speed was around 2 Mbps. Those days we started giving all our campus with network connectivity. I am telling about maybe around 2000, year 2000 or 2001. So what we had done, we were able to connect all our campuses. Also, we were able to have video conferencing Chennai, Bangalore, Hyderabad, Kochi. Because NITTI, you know, we do the training institutions. So teachers used to come to the physical classes those days. But when we connected this video conferencing, they are really very happy. So the speed 2 Mbps, we are able to do this type of program for 2 weeks also. So it is really helped people. So what I want to say is the 2 Mbps was a great thing there. So, but today we are really happy that we are all having like 100 Mbps connectivity in our institution. I'm sure all the government institutions, IITs, NITs, other institutions are having the connectivity of 100 Mbps. Now they have changed to 1000 Mbps. I don't know who is there. Anybody is there from your government institutions? So we have 1 Gbps connectivity. Okay. So this is really a difficult, great thing. So which is really helping us now, wherever you are in the world, we are able to connect like this. So we have to plan like this. Okay, the institutions, the technology, how the communication is developing is really helping us. We have to make our institutions to be like this. So the technology, how it was before and how it is now, we cannot imagine. So we have to make it successfully by arranging this type of connectivity, which is going to help us in the systems. Okay, so we try to develop this concept really. Okay. So this technology, what we are using for IoT concept is going to be really helpful. So I want every one of us should start thinking this. Okay, how to do this, how we can make it.
Sir,
It should be. Hello.
sorry for the interruption, Professor. Are you sharing PPT for the Professor?
Oh, not. Oh, Mr. Okay. 1 second.
Not sharing. Yes, Professor.
Yes, okay. Okay, this connectivity I was telling you, so which is really making us the speed. From that, it is changed to 100 Mbps to 1 Gbps. So now we have
Slideshow, Professor. Make it slideshow, Professor.
Hello.
Please make it slideshow.
Why not coming? I'll stop and do again.
Yes. Put it in slideshow, Professor. Yes, Professor.
Okay.
Nice, Professor. Okay, Professor.
So the speed is really very important, I want to tell you. So what is happening is that technology is changing. So this industry 4.0, we have a term called cyber physical system. I don't know how many of you are aware of this word, which is going to replace all the industry 4.0, 5.0, which is a synergist production of digital technology, the Internet of Things, artificial intelligence, big data analytics, machine learning, cloud computing. All those things I told. Okay, all these things are going to be combined, and which is going to help us to create the real industry 5.0 concept, which is going to be like this. This is the concept. The IoT or industry 4.0 or 5.0 is going to be cyber physical systems, where just now I was showing a video where there was a sensor. The watch I told you, there is an optical sensor. Here example is control. And I was telling the example about the autonomous cars or driverless car, where all the sensors are taken care as a control. And I told you the sensors are going to pick up the signal or send the signal to a cloud computer. That is communication. And in the cloud computer, it is going to do all the calculations, or it is going to make a decision just like a brain. So using artificial intelligence, machine learning or deep learning, this concept, it is going to be called as, this area is communication. So cyber physical systems, which are going to replace the term in future. So the next generation, whatever you want to say is, we call next generation is like cyber physical system, which is a system of collaborating computation elements controlling the physical entities. The cyber physical systems are physical and engineered systems whose operations are monitored, coordinated, and controlled and integrated by a computing and communication core. They allow us to add capabilities to physical systems by merging computing and communication with physical process. So this CPS is going to already doing a lot of things, but I don't know how many of you are aware. Some of the universities in India, they are offering ME degree in electronics and communication with specialization in cyber physical system. ME degree mechanical engineering with specialization in cyber physical system. ME degree computer science engineering with specialization in cyber physical system. As I mentioned, this is all interlinked. So we should be ready with this also, the technology which is going to be there, where this communication is like networking communication. It is anytime, anywhere, any place, anything is going to be there like this. It is going to be like this: social impacts and economic values, services and applications, security, reliability, trust and privacy, data volume. And everybody think that cyber security is also one of the important things. Whatever I say about network connectivity, whatever I say about speed, everything is changing. Now the least like connectivity, I told 1 gigabits per second we have. The speed is very good inside a campus. Or whenever I travel also nowadays, the speed is very good. You are going to have something like a VSAT, very small aperture terminal. There will be like LiDAR sensors, which is going to communicate directly like VSAT communication. So I always say VSAT communication example, you take the ATM. Everybody is using your debit card or credit card, you are going to insert it in your ATM machine where you are going to communicate within a fraction of a second. Imagine that. So within fraction of a second, it is going to a remote server and you are going to get the data that welcome Kulandai Whale and amount you are mentioning. So immediately it is going to check and tell you whether it is available or not. So we should be ready for these things. So the technology is changing to this type of communication, the real speed, which is going to help us in this type of IoT applications like intelligent home. So we are going to home, all the houses we are going to call as smart home. So simple example, assume I am staying inside my room. So I have windows. So I get the sunlight. So whenever the sunlight is there is no need of light for me. But what I do, whenever it becomes like dark 6:30, I go and switch on the light. So that work is no need for me. So there will be a light sensor which is going to automatically take. Okay, fine. Oh, the signal. Everywhere we will put the threshold. Keep a threshold and I make it. Okay. Whenever it is light is reduced, sunlight, it will automatically switch on the light. Morning, whenever the darkness goes and sunlight started coming, automatically the light will be off. Okay, this is one example. Similarly, assume a fan is there. So our air conditioner is there. Already people started doing like this. Okay, everything is going to be like smart. Or you take a street light. So many places we see the street lights are on everywhere. Okay, street lights are on. So what we used to do, street lights are on means people switch on that. Okay, there will be a plug they may took, or some nowadays they fix like a microcontroller. 6 o'clock evening in the on, 6 a.m. switch off. But if you observe summer time, even up to 6:30, 6:45, we have very good light. So what we are going to do is already in the smart cities they started, because wherever you are talking about IoT is smart. We call smart home, smart cities, smart health, smart manufacturing, smart grid if you are going to use electrical. So all these things are going to be there. Okay, everything will be smart. So in the smart street light, what is going to happen? Whenever the sunlight is reduced, automatically around maybe 6:45, 6:50, the sunlight will be on. Morning, sometime summertime, 5:30, light comes means, so automatically the light will be off. So this is how we are going to change. Automatically, that is we call machine-to-machine communication, like that you have to think. The communication will be replaced. You see the smart X-ray. Even the X-rays, so they are going to be, how many eggs you have got home. So whenever it is going to be reduced, automatically it is going to communicate. Or even if it is looking bad, it is going to tell. Like a smart washing machine. So some of the companies, they started doing, okay, smart ecosystem covering a wide range of use cases. Everything is like this. You take smart lighting like whatever I told you, which is going to control our bulbs one at a time or altogether. So find just the right shade of white, pick that perfect tone to match the moment, or recreate any color from the photo. So lot of things are going to happen. Smart AC, most of us know, okay, they take care of the schedule, usage to automatically maintain the perfect temperature and maximize savings at your home. Okay, whenever it's not necessary, why should you on? Sometimes we may forget to switch off. So automatically when no movement is there, it is going to find out. Okay, like a PR sensor you may be knowing. Okay, lot of sensors are there. Maybe just for idea, I can show you like there is a Tinkercad. I don't know how many of you are using. Take the case of Tinkercad. There is a software. So Tinkercad. So this is a simple example for you. So there is a software called Tinkercad, which is going to do all the activities whatever we do. Okay. So assume I am here now. So I want to have some simple like a smoke alarm. This is a real example of IoT. So I assume I have like this. Okay. So whenever you have this type of designs or circuits, it is possible for you to take these things. Okay. So we have like this different things. It is possible for you to take this. So try to take these type of things and you should be able to take this. Okay. For example, a smoke alarm is there. So these type of things are possible very easily. Generally, this also I encourage people. Okay. Even what will happen, the students may be having this. But in the laboratory, getting an Arduino may be very difficult because 6 students may be doing in the lab, but only one may do. But I always say that simulation is very important. Okay. So what we do, we make our people to utilize this type of programs. For example, you take, so all the things will be there. What I want to have like a sensor means I can take it. Photoresistor, push button, potentiometer, slide switch, force sensor, IR sensor, ultrasonic sensor, okay, PR sensor, soil moisture, till sensor, temperature sensor, gas sensor. So like that it's possible for me to do. So if I want to have something like Arduino, just type like this. So I'll be able to get this Arduino. Take like this and connect like this. Or I want a breadboard. Select like this. So any experiment for any basic things it is possible for you to do. Then we can write the code also here. So if I want to take a breadboard, yes. Yes, I want to have a resistor. Yes, it's possible for me to take a resistor. Okay, so whatever I want, like simulation, resistor, everything is possible. So now when I simulate like this, after connecting this, see, whenever there is a smoke, so smoke is not there, no sound. So automatically there is a smoke means suddenly it is going to give alarm or it is going to control. So like this, many things it is possible for you to do. This is one of the IoT experiments. So in case somebody is really interested, because I always feel that this type of things are very important. So I actually giving one general topic. This just for your information. Whoever is interested, day after tomorrow is the last date. Just go to virtual simulation. You'll be able to get the things. Okay, so like whether you are going to use MATLAB or whether you are going to use LabVIEW, whether you are going to use Tinkercad, Multisim LabVIEW, anything. Okay, all these softwares will be introduced. The free course, day after tomorrow, enrollment ends. Maybe if somebody is interested, just I can share it. You can give to your students or you can give to faculty members. So there will be a thing like this. So try to utilize, your people can utilize. Just anyway, I am sharing this. Okay, so whoever wants, just click this. As you can go through this because the simulation I always say it is very important. So click this sign in so that you will be registered so that you can get a course like this is like 8 week course we'll be giving. So whatever we have like recorded one or a physical whatever we have recorded through regular studio, people can go and use it, which is going to be really helpful for you. Okay, so this will be 8 keys. So you can have if you want you can credit also. And tentative examination will be 17th May. If you are really interested, attend the assignment. You can get this final exam. 100 question will be there. You can try to do that. Otherwise, it is not necessary. You can just understand the questions, try to utilize the material. That's what I want to suggest. But why I'm telling is people can understand about this also. Tinkercad also will be taught. So what I want to do is any experiment, any lab people are doing, you can do this. For example, you want to do like a, I told you it is going to be useful for agriculture purpose. So use this type of moisture sensor. So once you have a moisture sensor like this, it is possible for you to make like this. So people can do any type of examination. When you simulate, so all the sensors are available. You are going to click like that. So whenever you are going to increase like this, so based on this, it is going to give you the output. So these are things which are happening, but it is going to communicate one to one. See, assume this moisture sensor is there. I always say this, like water sprinklers are there, okay? Take this example. What we do, so I used to go and open my the water is dryness is less. But here what is going to happen? It automatically when it reaches the threshold, so the Tinkercad put you, okay? So assume there is a water sprinkler, okay? You are able to see this. So whenever I am going to have some control here, okay? So this I am going to fix something like this, okay? So click like this, I change like this, okay? It is going to be changed like this. Automatically this water valve will be open. Okay, so the sprinkler will open. So this is what is happening, IoT concept. So you have to remember this is this type of things are happening. So this smart agriculture or whatever you want to have, this will be like this. So smart AC or smart sleep systems. Everywhere people are using. Visualize your sleep cycles, understand what wakes you up and compare it. From the palm of your hand, you can control your personalized wake up and fall asleep. So all these examples are there, like smart weather stations. Yes, this is also one of the IoT. All are using our communication technologies. The Nitomat weather station allows you to use indoor temperature, relative humidity, COT readings to live in a healthier home. Even smart slow cooker. So we can enjoy this. Enjoy remote access to all your slow cookers functions no matter where you are. See, mobile is going to control you. Okay, this is what is happening. See, even the simple smart garbage cans. Everybody in India, we see like this type of things. It goes, garbage vans full of go, take it, everywhere it is full of, surrounded by lot of garbage. But some countries, they have sensors here. So whenever the garbage level goes certain level, it is automatically indicating to the control room, and we don't know, maybe some automatically the vehicle may come and pick up and go also. But at least our Indian situation, at least to give the signal, it will go, somebody may come and take it. So this we have to take care of this. Whatever positive points are there, we have to take care. Smart gardening. Bitbionics gives data on plants and conditions surrounding them for better gardening. Healthcare, I'll tell you a lot. Okay, example I told you just now also. Wherever you are here, whether you are traveling in ambulance or whether you are in any other place, so like a watch I showed you, wherever you are there, it is going to take care of you. The result will be monitored. Okay, it is going to help us. See, even the drones we told, okay, drones are going to help us. That is also IoT concept. I don't know how many of us seen this. So drones are going to help us in agriculture. Drone in agriculture, when you put, it is possible for you to find out how it is going to help us see the images. So this is also IoT concept. So automatically it may do, or it is going to be controlled. All these days people go manual. Just put see the manual fertilization, manual. People doing fertilizer. in farm field. Just idea I'm giving. So all this concept is going to change. So people go there and do all these things. So all these things are replaced by this drone. Imagine what will happen. Okay, similarly, robots are doing lot of functions. I don't know how many of you have seen. Robots are involved in the car manufacturing, where all these communications are happening. Their control room, nobody will be there in the real factory because I have some pictures, videos. Because of time, I cannot take like that. Okay, you just imagine a robot is going to control that, which is going to be controlled by automatically by machine to machine. Okay, all the manufacturing, everything is happening here. So you have to be ready for this. So the concept is changing nowadays to like this. IoT in healthcare, that's what I told you. Industrial use, you see, we are calling this as smart industries. So all these things are IoT applications. So wherever you take smart homes, I told you, even the smart city I was telling you. Okay, all over the world it is going to be connected. You be ready with this. This agriculture also I was telling you. So wherever you have, it is going to be like this. You be ready for these things. Okay. People should be ready for these things, which is going to help us. Okay. Everywhere in the world, it is going to be changed. So we should be ready for these things. So think how our technology is going to help us. IoT in farming, I told you. Even the smart supply chain, whether you are going to take like logistics, so from a ship, things are going, or a freight cargo, things are going. It is going through a transport like a vehicle. All these things can be monitored. So even a vehicle is going to stop for a long time, you will be able to find out. There is no issue. Okay. Assume somebody is taking some of the ration items. Okay. In case that is going to take for a long time, the vehicle is stopped for a long time. It is possible for it to find out what is the problem. You can find out why. Immediately they can check, monitor why it is there for a long time, stopped for a long time. This is what. Even for shops, they say smart retail. So whatever items want, I can buy. So whenever I buy, automatically the data will be reduced from the database, and automatically the signal will be going to different places, and the things will be delivered. So the limit, there is no need to monitor personally every day. So automatically it can be found out. This is what I told you, like transportation of vehicles. See, everywhere we are going to have this type of communications. Okay. Without this communication and cloud, okay, there is a computer you have to remember. This is what is going to happen. Mobile, you can monitor everything. Maybe I'll tell you the technology is what we are telling using also. Even the wearables all over the board. Only one I told you ECG. But you are going to have like ear wearable, smartwatch, okay, smart socks. Everywhere portable, you are going to have fitness bands, e-books, wearable eyeglass. So like this, we are going to see in future everywhere. So you have like this, like a blood pressure nanosensor, pulse oximeter nanosensor, gateway, nano micro, ECG, everything you are going to have. So which is going to help us to do these things. Okay. The concept is same. You just remember this concept itself is enough. Whether this is a human being, whether it's a transport vehicles, or whether it's related to agriculture sensors, or whether it's a smart cities, the sensors, the concept is same. Internet will be there. It is going to communicate. It's going to give the output. Okay. So take the example of smart transportation. See, everywhere it is connected, whether it is going to connect to satellite or terrestrial broadband communications, or this type of mobile communications, or the Wi-Fi communications, or anything shipped to this communications. Anywhere you have, okay, adaptive cruise control, fleet management, toll collection, trip planning, traffic signs, theft systems, or even the intermodal communication like metro trains. I think many of you may be knowing already metro trains in Delhi is operated without the driver. Inside in India, including Chennai, they started metro nowadays, one or two they have done trial, so which is going to help us. So this type of driverless car has come already. Okay. Maybe I think if something is there, I can try. Okay. Later I can show you. Okay. driverless car. See, person is going to operate like this. He or she can, we can read or eat, nothing problem. The car is going to automatically do all the signal processing, image processing, whether anybody pedestrian is crossing, everything will be monitored. I'll try to explain later. So the concept is changing to Internet of Everything. That is people to people machine, people to people communication, or people to machine communication, or machine to machine communication, or all the network connections or knowledge process. Everything is interconnected world. This is what I told you. The paradigm of Internet of Everything is advancing towards enriching people's lives by value to Internet of Things with connections among people, processes, data and things. Everything is interconnected. You should be ready to do. Okay. So please plan. That is what I want to tell. So whatever you do, it is going to be connected. Without our knowledge, all these things will be happening. Okay. Maybe I'll just check some videos there. What is Internet of Things? You can just see here.
The Internet of Things, or IoT, is influencing our lifestyle from the way we react to the way we behave. From air conditioners that you can control with your smartphone, to smart cars providing the shortest route, or your smartwatch which is tracking your daily activity. IoT is a giant network of connected devices. These devices gather and share data about how they're used and the environment in which they're operated. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analytics is performed on the data and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product was distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for the repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge. Business Insider Intelligence estimates that 24 billion IoT devices will be installed by 20.
So it is going to change fully. Whatever we expect now, it is going to be changed. That's why if you compare olden days, the internet appears everywhere in the world. Okay, initially only for connection between people. We are using only for communications. But now Internet of Things is a plan to connect things also using the same medium. So if you see the generation, how it was changed, pre-internet, only human to human was there, where we had fixed and mobile telephony, SMS. Slowly Internet of content came. That is email, information, entertainments. Then slowly Internet of services came, Web 2.0. e-productivity, e-commerce, smart IT platforms and services, then Internet of People, social media, Skype, Facebook, YouTube, then smart devices, objects, data cap. Then Internet of Things, machine to machine, that is identification, tracking, monitoring, metering, automation, actuation, payment. So the smart concept has come with data and ambient text. So this is how the technology is changing. So we should be ready for these things. Slowly the concept is changing. Okay, if anybody wants the real definition, Internet of Things, popularly known as IoT, is the technical concept that allows various digital and mechanical computing devices, humans with unique identifiers, objects, and even animals to stay connected. Okay, that is what is going to happen. Even the animals are going to be connected over a general platform in order to communicate and transfer data without any interactions between humans or computers, but with an IP address. I'm sure all of you are aware of, okay, what is the IP address? You have to know. Okay, that is very important. The IP address, we have like this. Just remember, IP V4 versus V6, we should know this. All of our devices, sensors are going to be like this. Because each one of us have a mobile number. Like this, each one of us will be having a IP address. So if you take like this IP address, we have like version 4 and version 6 like this, where it is going to be, because like that was there. Okay, it was like this initially, but slowly what has happened, the concept is changed. This is for other branch people, computer people, you may be knowing this. So if you see, version 4 and version 6 is like this. The number is, it's called numeric dot digital notation. See 192.168.5.18. But now, because each website address or each sensors are going to change the value. We change like alphanumeric hexadecimal notations. See, it is going to have 128-bit address. See, initially it was only 4.3 billion address. Because now many websites, many YouTube, many Instagram, each one is one link. So it is not enough. That's why now they made 7.9 into 10 power 28. That much addresses are there. Automatically that is going to take care of this. So each sensors, everything is going to have a value which is going to be really beneficial to us. Okay. So we are going to have this type of things. Each one will be having a IP address. So we should be ready for these things. So as I told you, it is all constantly transmitting data and talking with one-to-one. It is going to happen. So we should be ready with the other devices. So some of the connecting devices like this, as I told you, it is connecting, or like you take a transport, okay. You take a transport device, it is going to be like this. A GPS satellite will be there, it is going to track the vehicle, okay. It is going to be connected through a cell tower. It is going to connect to a cloud server, which I told you. Somebody like fleet manager or owner are tracking their vehicles and assets. Okay, it is going to happen via the internet connections. Automatically, this is going to happen. So we should be ready for these things. Okay, technology is changing like this. Because as I told you, the speed is very important for this. So we have to have healthcare, energy, building, retail, agriculture, security, home, education, transport, factory, everywhere they are going to there. So we should be ready for these things. I think because of time, I'll try to skip some of things. Okay. So we'll be having this type of connectivity everywhere you are going to see. See, when your robot is there, it's going to do like this. So many, and slowly the industrial IoT concept also has come. So now whatever industry we told, smart manufacturing, it refers industrial Internet of Things, which refers to the deployment of small sensors, sometimes with computing capabilities, that collect and monitor data in real time throughout the business. So these IoT sensors can be deployed in conjunction with basically anything from lights to heating, ventilation, air conditioning to factory floor machinery. Industrial IoT is foundational technology of Industry 4.0. As I said, many benefits are there. It provides insight for better decision making on many levels of the organizations. If you see the car manufacturing, okay, it is possible for it to do this. Many things are happening. Okay, factory automatically the painting will be done. Automatically the things will be door will be closed. That fixed everything will be done. So you take all the operation in a factory, whether it's a factory software IoT solutions or R&D team, operation and supply chain area, financing, robotics, CMC controls, machines, machine components, service department, aftermarket. Everything is interconnected by this. So future we are going to have all these things in IoT, where we are going to have upticks in production throughout. Each machine on the production floor has an IoT device. Connected to that, it monitors production efficiency, usage uptime, etc. So then this data can be used in conjunction with a machine learning algorithm. This determines which piece of machinery represent the highest priority bottleneck as well. Okay, so we have to see this. Okay, how the technology is changing. As I told you, cybersecurity is also very important. In case you want to have like a real architecture, you can see like this type of different microcontrollers are there. As I told you, it is going to help with the help of GPS, GSM, Bluetooth, Zigbee, fingerprint technology, RFID technology, actuators, analog to digital, digital to analog, input devices, output devices, Wi-Fi, everything is combination. Okay, it is going to work for the IoT related. We should be ready for these things. All the technology. So people started developing this type of technologies. So people should try this type of experiments in your laboratory, because they have like a sensors nodes, which are going to be connected through this type of IoT builders. A lot of cables are there. We should be ready for these things. A lot of nodes have come, lot of developments has come. Please try these sensors. You can try with your experiment, which is going to really help you. Okay, especially with GSM technology, how it is working, Zigbee, how it is working. So people are doing different experiments. You should be able to do this, even for smart health. Because of time, I'll skip these things. Okay, but whatever you do, the real concept, as I told you. Okay, you are going to have a patient monitoring sensors or like room condition sensors, whatever you have. So it is going to connect with the power supplies and some of the microcontrollers connected to the web server, then through the user interface, and long distance persons can monitor. So the same thing you can use for any of the purpose. Okay, whether you are using ESP32 heartbeat sensor or body temperature sensor, room temperature sensor, CO2 sensor, many things you can use. Okay, a lot of technologies are there, a lot of other things. Because of time, I'll skip. Just for the idea, I'm telling you, you can have any type of sensors: pressure sensor, temperature sensor, chemical sensor, motion sensor, proximity sensors, image sensors, optical sensors, water quality sensors, smoke sensors, infrared sensors, level sensor, gyroscopy sensor, accelerator sensors. You want to see how it really looks? I can give you the picture like this. Okay, this type of sensor, thermistor, how it look like. IR sensors, IR sensor like transmittive type, reflective type, ultrasonic sensors, gyroscope sensors, accelerometer sensors, rain sensors, soil moisture sensors, which I told you. Okay, photoresistor sensor, water flow sensors, heartbeat sensors, alcohol sensors, color sensors, PR sensor, gas sensors, smoke sensors, LM35, IR receivers, LDR, humidity sensors, flux sensors. Okay, solar, everywhere you have. Okay, real time like this. So all these concepts are going to help you. Even the grid, smart grid also, you are going to have many of the things. I'll skip some of things because of time. I'll skip it. See, this is what I told you. If you take a car, so it is going to be fitted with all these sensors. Okay, many sensors. Lane departure system, night vision system, everywhere sensors. Front object CCD cameras, front airbag sensors, ACD, nighttime pedestrian warning, drowsiness sensors, front object laser radar, nighttime pedestrian warning sensors, active park assistant, tire pressure sensors, rear object monitor, CCD camera, rear camera, side curtain sensors, blind spot detection, cross controller, central computer, rear object laser radar, wheel speed sensor, the pressure sensor, collision sensor, side airbag, SRS, adaptive cruise control, steering angle sensor, automatic brake control, wheel speed. So like this, we have many things are there. I'll just check if possible quickly. I can show one taxi if possible the video. Okay, just observe. If it is there, you see the future taxis are going to be like this. Already it started coming like this. Just observe how this technology is coming.
A self-driving taxi service called Waymo is coming to Los Angeles.
The service already up and running in San Francisco. Rich DeMuro takes us for a ride in one of the cars in today's text farm.
See how the communication is happening.
Here in San Francisco, where Waymo has fully autonomous cars picking up people and dropping them off, just like a taxi, except the big difference is there's no driver. We got to try this out. The way you do this is kind of like any other rideshare. You open up the app, 555 Laguna Street, $9. It says, I'll see you in 8 minutes. The ride is about $9. While we wait for this, I'll tell you about the car that's going to pick me up. It's a Jaguar I-Pace, all-electric car. For safety reasons, the cars stop in certain areas to pick you up. And so on your app, it'll tell you I should walk 90 feet ahead to where it's safe to pick me up. So there's the car. Oh, that's so cool. You use your phone to unlock the car, then you can open the trunk, put your stuff in the back, and let's go in. Oh, this is so wild. Here we are inside the self-driving car. It says, good afternoon, start ride, and I see my destination.
So when I
right
put
there.
start, that's all.
And I even have a place to charge my phone. All right, to start the ride, here we go.
Heading to Ben and Jerry. Please make sure your seatbelt is fastened. For any question,
Oh my God.
press the call support button to speak to the rider support agent.
It's cruising the street just like a regular driver would. We're actually passing another Waymo. They honk to each other. And I love that you see the map on the screen here. What's really interesting is that this car is very sure of itself. It's not like creeping along the streets. It's driving like a real human would. So you feel like it's confident about what it's doing. The best part is watching the wheel move all by itself.
Proceeding on Waller Street.
You got your map view, your music, oh, your temperature. You can even adjust the temperature. Oh, that's cool. Oh yeah, here we go. We got a truck that's in our lane and we're just going.
See, imagine how the real communication is helping us. Within fraction of a second, this is communicating to the server, it is operating.
If you're sitting where I'm sitting, you really wouldn't even know there's not a person in the seat in front of you driving.
You're here. Please make sure it's clear before exiting and don't forget any items in the trunk.
Okay, that was a pretty neat experience. I've been in lots of cars where there's a driver. Even without a driver, it felt safe. It was fun. The Waymo handled these streets with ease and even opened the trunk for me. Pretty neat. In San Francisco, I'm Rich DeMuro, and you are Tech Smart.
Okay. So this is what is happening now. Automatically it is going to happen. Okay. The people already it is changing. The technology is there like this. Because all these sensors are there. Anyway, we don't know what is there, everything. We'll just see the real car, which is going to be like this. So that technology is changing like this. So we should be ready for this. See here how it is going to change. Okay, it is going to have all these global positioning systems, light detection. Okay, LiDAR we call light detection and ranging, rear cameras, sensors. Okay, odometer sensors, central computer, remote radar sensors, video camera. This only few. Okay, all these things are going to happen where you have all the self-driving will be there. Okay, pressure monitoring system, electronic stability control, advanced airbags, anti-lock brakes, headlights, rear view cameras, lane departure warning, adaptive cruise control, automatic energy braking, blind spot detections, all whatever you want, whether it's a racing car or medical car, car, tourism travel, military, construction, farming, warehouse, cargo, freight, delivery, parcel, commute, task, shared, owned, retail car, shuttle service, ride, or anything. So we are going to have this type of autonomous vehicles, okay, which is going to really help us industrial purpose or specialized one, transportation, consumer logistics. So what I want to say is people should start planning this type of different types of experiments. Try to plan for your like electronics and communication people will give the real hardware. Okay, as I told you, try to make them to work with this type of things like whatever you have virtual simulation I told you. Okay, where people can try this Tinkercad. Okay, where it is possible for you to do any of the experiment. Okay, drive like this. Okay, any sensors if you want to do. So select these sensors. Ask your students to do this physically. Okay, any sensor if you want. Okay, I want to have IR sensor. Yes, take this PR sensor. You can take like, and you try to connect this and make your students to do these type of activities. So once you do this, your students will not forget this in their life. So make this all these things as a experiment and make your students to work with the real concept so that they will not forget this in their life. So make this type of simulations. Anyway, a lot of other things are there. I think better to have the finish it with a summary, all these things, important points I want to say and close it. So many things that have come now. Future we are going to see all these things as smart concept. Okay, whatever you are going to see will be smart. You have smart concept, which is really going to help us in completing the future will be like this. Okay, the small is going to be called all like smart things. And whatever we are going to see, all these things are very less. Okay, the autonomous vehicles, traffic management, infrastructure, revenue, liability insurance, many challenges are there. And I am telling to all that we may have a lot of issue for the jobs also. We lose driver jobs. If drones are coming, many of the agriculture people will be in trouble jobs. Or I think you know, drones are going to deliver food in your house. Or it is going to deliver the Amazon package. So we lose those jobs also. Whatever you do, many issues will be there from industry 4.0 to 5.0 or Internet of Things. All these things are going to have many impact. But I want everybody should start doing some of the real communications. You plan how to do this. Try to make your students to work with IoT, microcontrollers, so they will get a job. Or make them to know how to repair or service a drone, or how to operate with a robot. Like a latest technology, try to bring, okay, so that they'll be able to do. So whatever we have discussed is only maybe 1% or 2%, or whatever existing now it is only we call iceberg. You can see Titanic movie, you see only in the top they see that iceberg, but under that it was there, nobody observed and it hit. Similarly, we have many things are there. So I want everybody should develop think like this, how this one society 1.0, 2.0, 3.0, 5.0 going to change us. What smart society will be there, industry 5.0. We should be ready for this. To smart government, smart environment, smart economy, smart people, smart institution, smart technology. So to make our super smart society with all these things, because all of us are going to become like a smart people. So like smart living, smart governance, smart economy, smart environment. So where we are going to have, I told you, human-centric society we are going to have. Just like a robot I told you initially, starting with the hand, robot hand and human hand, if it comes, nothing will happen. It should stop. Okay. So it is should be like via humans and automated process data driven should happen. Knowledge intensive society should be there. Merging cyberface with physical systems. So finally we are going to have sustainable development, new social welfare, new system methodology, super intelligent society. So thank you very much for giving an opportunity to summarize. So from industry 1.0, 2.0, 3.0, we are coming to the 4.0 to 5.0, which is smart society, which is going to change the way we live. Everything will be changed future. But we may have a lot of impact. Impact means positive also there. Some of the negative people feel we may lose a job. But we should be ready for these things. Okay. So try to work with this. Whatever you want to do, please try to do so that it is going to be really helpful. Try to work with the people. Try to learn many things are there. So that is what I want to conclude. Try to make the things such that everybody in the world will be getting awareness, because I told you the concept is changing. how it is happening in the world. We have to make our systems to ready. So whatever branch, I always say this, okay, don't think that I am from this particular branch. So I am from this branch like this, don't think like this. So you be ready to manage any of the things. Okay, whatever branches, yes, you have the option, okay. Try to do that so that everybody will be there, will be benefited. And we have a lot of job opportunities also. Don't think that this is going to replace me like this, okay. And thank you very much. Anyway, I have given my number also. So just enjoy the class, and you can enjoy, you make your students also to really use these things so that it will be really helpful for them. That's what I don't think this is like a theory class like that, because all those things are going to be replaced. Okay, you make such that this type of technology is going to help. It is a real thing like that. You have to think we are going to face this type of things. How to achieve this or how to manage this type of classes? To think that will be really useful for you. So just if you have any questions, you can tell me. Otherwise, as I told you, you can try to join the spiritual simulation course. Anyway, I'll be there to help you through WhatsApp also. We can communicate. Not only this topic, we will be able to get a lot of ideas through these things. So hope to enjoy the evening. I know it is very, very difficult, especially family people, how to manage. Even though you missed, at least I want everybody has taken some few points. I'll be really happy. So wish you all the best. Keep in touch. If you have any issues or you need any help, please contact me through WhatsApp. But I'll be most of the time busy. But if at least personally, if you need any help, I'll try to help you all. Thank you all. Thanks for the opportunity. Anyway, I'm posting again that link. Whoever wants, just click that and you will be able to use that one. Okay. Thank you. Thank you very much.
Dear Professor.
Yes, sir. So is it audible?
Professor?
Is it audible?
Yes, you are audible, Professor.
Thank
Thank
you,
you, Professor. Actually, we have also posted your the NPT that Shwam your course in our Atal participant WhatsApp group as well as in a college group.
Who is interested?
Definitely,
Because it's free.
all the members will register your course and get benefited and make it to be useful for the students and the future generation.
All the students can be benefited
Of the enormous work done by yourself and the government, NITTR and Government of India. Actually, your depth of knowledge in IoT, Industry 4.0, 5.0, and the revolution of changes in the network technologies, industrial IoT, and super smart 5.0 was very remarkable, very interesting and impressive. And most of the participants have gained much knowledge from your presentation. Having heavy, hectic schedule on various meetings and agendas, you have agreed to participate us, and we were very afraid that we want to make your presence felt by making many people to join and listen to your presentations. Definitely, it was very nice presentation for the future generation. Thank you, Professor. I want the participants to discuss, to ask a few questions if they have in their mind. One such question was, what is the difference between IoT and IIoT?
See, the concept is same, sir. Industrial Internet of Things is everywhere. Because I was telling you many applications, okay, whether it's a smart home or smart health or smart cities or smart grid. Because when I am going to use wind energy or solar energy, because olden days, the energy, because I could see in the southern part of Tamil Nadu, example, windmills, that turbines were switched off. When I usually ask, they say, sir, it's a problem, sir, because we are not able to distribute the electricity, whatever we are doing. But now what has happened, all this concept is changing. Automatically, because of IoT, you are going to have automatically the distribution is going to happen among it. So from rural part of south or southern part of Tamil Nadu, it is coming to Chennai. Okay, Chennai also it is distributed. Automatic distribution is happening in smart grid. So if you are going to use, especially for smart manufacturing, or if you are going to use for industry, people call this as industrial IoT. Internet of Things is everywhere for all the things. Common name is Internet of Things. When you are going for industry, you are using, people call this as industrial IoT, Internet of Things.
Yes, Professor. One participant wants to interact with you. We unmute him. He will interact with you for a few minutes. Yes, sir. You can interact.
Okay. Thanks for the opportunity, sir. Really, it is very nice lecture to hear from such an eminent personality. Sir, actually, I'm currently working. My name is Shyam Sundar, sir. I'm currently working as an assistant professor in Department of Artificial Intelligence. And so, if I come to IoT, actually, I'm interested in working with VANETs, vehicular ad hoc networks. So, for that, I have, when I was searching for the literature, I have found two promising softwares. One is TUMO, simulation of urban mobility, and second one is discrete event simulator. Sir, like I'm trying to by trial and error method, I'm trying to do some simulations, but the help for these two softwares is very less, sir. Like even when I search through YouTube videos, I can find only limited help.
What sir? Can you just tell me again? Net that's coming again. Vehicular area ad hoc networks. What do you want?
Actually, I'm interested in VANET, sir, vehicle ad hoc
Yes,
network.
vehicular ad hoc network. Yes.
So when I searched for the literature, I found two promising softwares. One is SUMO, simulation of urban mobility, and another one is a discrete event simulator. So actually, when I'm working with these two softwares, I mean, there is actually limited help in the online, sir. Even when I go through YouTube videos, etc.
Yes, yes, sir. Because all these things are just new only. So if you
Yes,
see, that's the reason. That's why I'm telling all are emerging. Especially for
Yes.
India, the problem is because as I told you, the communication. Because whenever I travel, I have mobile. Many places you don't have the good connectivity. Okay.
Yes, sir. Correct.
That is the real problem. That's why India it is not coming. So communication it will take long time. Even the roads are really not in good condition. So that is the reason. But what I suggest is whether it's a discrete event simulator, okay, which is like modeling technique people are using, or TIMO, I think like single input, multiple output concept, or whichever. So my suggestion, please start using this. So if you are going to do this project, at the end when you complete, it will be real question. So I am sure whatever software like Tinkercad, I was simply example. I have like
Yes, sir.
MATLAB, LabVIEW, I have, but because of time I couldn't show. Like all these IoTs application, many things are through internet LabVIEW software, laboratory, virtual instrumentation engineering workbench, or MATLAB. If you go, a lot of IoT is there. You can try everywhere. You have a lot of help. Try to work with the things so that it will be easy for you. Because as on date, as you said, it is very less. Okay, that is the problem. People are initial stage. Really, if you are interested, try to visit somehow. Like I was there sometime in NTU Singapore, where I could see they have done really autonomous vehicle. They have a design, and I could see. Chennai also, India also, we have. Even in Chennai, we are arranging one autonomous vehicle, but it is a model developed by our people. So what I say is, try to find out some particular website US or NTU like that, or you can try to approach some of the NTU people personally. They'll be able to help you.
Okay, sir. Definitely, sir. Thank you, sir. Thank you very much.
Thank you.
Thank you, sir. Thank you, Professor, for interacting with participant.
Sir. Hello,
Yes.
sir.
Yes, we can interact with Professor.
Sir, actually, I'm Vanita, working as an assistant professor in the Department of Computer Science, sir.
Yes.
Sir, my doubt is I'm doing my PhD work, sir. My domain is vehicular edge computing, sir. The application I choose is that is healthcare, sir.
Yes, madam.
Security in healthcare. So I'm having doubt which simulation tool I can prefer to do my work, sir. Which one will be
विधानसभा में अंदर पीछे वो बैक साइड में रजिस्ट्री ऑफिस के ये है नहीं
sir? Hello, sir.
Yes, madam. Can you hear?
Yes, sir. Yeah, I can hear.
Yes, madam.
Sir, actually, my domain is vehicular edge computing, sir.
Yes,
In that,
madam.
I have chosen my application is healthcare.
Yes.
What is the problem I am going to address is security in healthcare only. I'm just doing my PhD work, sir. In that, what my doubt is, which simulation tool I can prefer to do my work? Which one will be better, sir?
Whether you have tried with LabVIEW or MATLAB?
No, sir. I didn't try now. I'm just studying. I'm just reviewing. I completed my review paper alone. Hereafter only I'm going to proceed, sir. I have studied the paper. Health, the data set can be get from Health machine learning repository like that. I have read, sir. I just wanted to know which simulation tool will be better to proceed my work, sir.
No, my suggestion,
Please
madam,
suggest, please.
whatever simulation is there. So if you want to have just like a MATLAB, LabVIEW, they have developed a lot now.
Yeah.
Okay, so minimum MATLAB. I'm sure in your colleges, MATLAB will be there.
Yes,
Okay,
sir.
so try to approach the engineer who is dealing with that, or what you do. Anyway, you contact me. I will link it to that people, so they will be able to tell you. Okay, that is better.
Okay, sir.
Okay, at least go through MATLAB and LabVIEW, put this word. But as I told you, it is really a new area. People have not done much work.
Yes, sir. Yes,
Okay,
exactly.
because as our one of the participants told, like SIMO or DS, like that he was telling. Okay, so we'll try that, but really healthcare related people are doing, but not much simulation, particularly for that has not come much. So please try with MATLAB LabVIEW, otherwise we'll try to find out, madam.
Okay, sir. Okay, sir. Thank you very much, sir.
Thank you.
Thank you, participant. Thank you, professor. Now we will have a photo session. Please, all of you, switch on your camera.
Do you think now people will be there? Many will go.
Yes, professor. All are there, professor. They are all listening to your presentation.
Is it audible? Is it okay?
Yes, sir.
Okay, okay.
Yes, sir.
I don't know, only sir should, Inna sir should tell. Okay, sir.
Thank you, professor.
Thank you, sir.
We thank all the audience for having actively participated in all the sessions and
Thank you,
interact
sir.
with experts.
Really,
Thank
we
you
have to
all.
thank
Thank
them.
you all.
Thank you, thank you. Thank you all. I'll close, okay?
Yes, sir. Yes, sir. Yes, sir.
Thank you, thank you.
Thank you. Good night.
Good night, sir.
Dear participants, kindly fill your feedback link in the chat box. So we request all the participants to fill your feedback link which is posted in the chat box. Kindly fill your feedback by using the Atal registered email ID. Thank you. Thank you for your cooperation.
பழைய ஊற வைக்க நல்ல கலந்து முடியா தண்ணி ஊற வைக்கணும். கொஞ்சம் சாப்பிடு குடிக்கிறேன். குழந்தை